Right. So, I can too. That's much cleverer. Number 2. Box of supplies are dropped from the helicopter moving 80 metres per second. The supplies hit the ground 9 seconds later. With this set of questions, they give you a scenario, and then they give you a whole bunch of things to find out. Some of them are silly because they actually give them to you in the question. Some of them sensible. That one there. Isn't that the... We're talking about...
He said pointed to that one. And said
there, projectile problems 1. Question 2. Okay. Arnie. What's your first step in any problem? Draw the problem. So I'll do it over this side of the board so I can see what's going on. See how the helicopter? That's rather disappointing. That's better. I want a box that I can draw into. So now you can see what's going on, the questions over there. So in this case, I'll draw a simple little helicopter. I always like to be artistic, you don't have to be. And you drop a box of supplies. The helicopter is moving along with a speed at 80 metres per second. And that box will do a little parabola thing down like that until it gets to the ground. Looks like that. And you're told that it takes 9 seconds to fall that distance. Which I'll just write there. And then next to it, I would encourage everyone always to do this, is to write down the things that you know. So you put your data down, or data. And there's some things you always, guys, need to write down and remember. The first thing, of course, is that you know that your initial speed u, or initial velocity u, is 80 metres per second. You know the time, which is 9 seconds to fall to the ground. And you always put this in. You always put AY, which is G, which is 9.8 metres per second squared. Right, yep.
When you're writing stuff like that up, should you put like the vector arrow, so like 80 metres per second, and put an arrow to the right? Because
well, at that first instance,
you can. Then the first question you're asked is question A, which is the initial velocity. Well, that's a silly question because you know it. That's right. So A is 80 metres per second. I'm not going to write that up. B, they ask you the initial horizontal speed. Now, horizontal. All of it is going sideways. And guys, if you're not listening, it's obviously going to confuse you. So it'd be good if you did this with me. Everything is going sideways. So question B, which is find UX, this one you can just do by knowing, is 80 metres per second, which means that the next question C, which is the initial vertical, because all the motion is sideways, that must be 0. Okay. No, it's a box coming out of the helicopter. They're dropping it. So someone's flying along and they throw a box out the window. Yeah, it's sort of a helicopter. It's only rough. Right, let's see.
the final horizontal velocity. Yeah.
Now remember, and this is true for everything. What's sorry, what's D? I've got it D. What's D?
It's range.
It's range. Now, sometimes you can't do things in the order they give them to you. And I know from experience that trying to do range is not going to be easy. Now I can learn that by looking at my formulas that I have. If you look at the first question, range is delta x. Yep.
It's the formula for that.
Yes, I know, but hang on. Let's look at them. So I look at the first formula on the board over that side, v equals u plus at. That doesn't have delta delta x in it, so it's no good to me. The second one, v squared x equals u squared x plus 2a delta x. That does have the range in it, okay? But the problem is, if you try substituting that formula, what's the a horizontal acceleration? No, the horizontal acceleration is 0. It's not being accelerated. So in that formula, you end up with the range part of it being cancelled out. So go to the next one. Delta x equals uxt. Now I'm in trouble because I don't know ux. I don't know delta x, I should say. I know ux, but what do I know time? 9 seconds. Okay, so maybe I can use that. Let's see what we can do. So I go delta x equals uxt, which is going to be, you have to remember this, and this is where people get lost. That's the speed sideways or horizontally, but there is no acceleration in the x direction ever, unless there's a rocket attached to the back of it. And they're going to give you a question with a rocket attached to the back and ask this stuff. So in my data up here, I could have added ax equals 0, just to remind me. You can write that down for every question, it will remind you of it. And so when I do this, it's uxt plus a half axt squared, but because that is 0, the a, that bit doesn't bother us. So I'm going to end up with 80 times 9, which is going to be 720 metres. So that's easy enough. Question E. What is E?
E is final horizontal velocity.
Okay, the final horizontal velocity doesn't change. Vx equals ux always is the same, so that's going to be 80 metres a second minus 1. Next one.
The final vertical velocity.
Okay, so I have a number of formulas over there. I'm looking for a formula which has v in it. Which formulas satisfy that?
Vy.
Yes, so I've got vy equals uy plus ayt, or I've got vy squared equals uy squared plus 2a delta y. Now, if I look at those, how would I work out in my brain which am I going to use? Let's look at the second one, the v squared equals u squared plus 2ay. Okay, do I know v squared? No, that's what I'm looking for. Do I know the u squared?
Yeah.
Yes, I know that, so I've got one variable there. Do I know the a?
Yeah.
I do, so that's okay. Do I know delta y? No. So I've got two variables I don't know in a formula. I can't solve it. I could do it simultaneously, but I'm not going to bother. So what I do is I then go to the equation that says v equals u plus at. I don't know v, I'm trying to find it. I know the u, I know the a, I know the t. Oh look, there's a formula with three variables used.
So you don't know like what the formulas have to do, you just have to figure out where to input your numbers, then you only have one missing variable.
That's it. So v equals 0, because the starting speed downwards was 0.
As long as we can put things in.
As long as you put them in, it works.
Trying to work out the speed, it's not used like a formula for
So that's going to be what? 88.2.
What I got.
That looks right. So g is going to be the final velocity, isn't it?
Yeah.
Now, the final velocity, don't forget, is the sideways velocity added to the vertical velocity, so you get a resultant. And that there is your final velocity. So that's going to be, of course, 80 there is the horizontal. The vertical we just found was 88.2. And that means that when you use Pythagoras,
So it's its final velocity when it reaches the ground, not because it accelerates down. That's
Yes.
what tripped me up because like it's not a constant velocity
roughly
down.
about 92. I don't know, I didn't use a calculator.
taking the righty brain method of working it out, and there's going to be an angle you have to work out using trigonometry. Okay? Now,
roughly about 30 seconds.
Brad, you're quite right. Has anyone got it?
119.
Wow.
0. No, I rounded up 8.
Oh, what is that? The hypotenuse?
Yeah.
That's that. So, the Riley calculator's just had a moment. That's okay. That's the final velocity, and you need to find the angle in there. But, oh, sorry, actually, probably that one's better. In there. And you can do that using trigonometry. I'm not going to bother. You guys can do that because you do maths. But what Brad said is quite right. That's the final velocity there. We're at 9 seconds of falling.
So why do we need to use trigonometry if that's it?
No, the trigonometrists find that angle.
Could be 42 degrees and 12.
Because you need,
Oh.
being a vector, you need an angle.
Oh,
Okay?
Can't you just say down?
No, because it's not down, it's at an angle.
Can't you just say down side place?
42 degrees.
I don't know, but it could be around. Yep.
Is it the angle that's like the dot, or is the angle that's down?
I said
like,
37.
You just need to specify. If you found that one, you can say 70 degrees from the vertical. From the vertical.
I just said 37.
That's vertical.
Which way would the arrow point?
Well, the arrow's going down that way,
Yeah.
right? So that arrow is either at 42 degrees to the vertical, or it's at 38 from the horizontal.
Right. Yeah.
Doesn't matter.
That's the part where it's coming from.
Yeah,
Wait, but we use
doesn't matter.
diffuse bearings or
Yeah, you can use on this because it's an angle to the ground. Use the angle to the ground, guys. I'll say this once more for you. Don't get sucked into this thing where what a lot of students do is they get the v equals that number and they think got the answer and they forget that velocity is a vector and you need an angle. Now, as I was just saying to Brad, there's the ground and it's going to hit the ground at an angle. Now, it doesn't matter as long as you can give an angle. I can say it's at 42 degrees to the vertical, so that's vertical. It's at 42 degrees to the vertical. Or I can say it's at 38 degrees to the horizontal. As long as I give them an idea what the angle is, you can say whichever.
80 over 88.2.
Yeah. Yep. Yep.
48, not 38.
Now, Brad also raised the point, as I said a moment ago, that that velocity is there. What happens at 4 seconds into its flight? The way you'd work that out is very simple. Here, v equals 0. It still starts off at 0. It's still falling with an acceleration 9.8 metres per second squared. But instead of timesing by 9, you times by 4. If we're doing it for 4 seconds, or 5, doing by 5. That will give a new vertical speed,
38.6.
38.6. So then it goes 80, 38.6, and that'll tell you its total velocity
Yeah, right.
5 or 4 seconds into its fall. Okay. Okay? Next question. H.
The brain coach will be pretty happy with that.
Time taken to fall, which is just 9 seconds.
Not good on brother.
Time taken to fall is 9 seconds. That's easy.
What if we get G?
Bye.
Where do you get 42 degrees?
Okay, to get 42, and I'm listening to Riley, who told me that's right. So if it's wrong. So what we did was we took the tan. Which one of that one? So let's call that alpha, just because I can. Alpha will equal tan minus 1 of 80 on 82. 88.2, which should equal, according to,
is it 42 from the vertical or 42?
yeah, he's found alpha.
He's right, because it's 48 from the horizontal.
That's 80 on 8. 88 on 5. That's all I have.
Opposite and adjacent.
I was trying to find the angle to the horizontal.
You can if you want, it doesn't matter. You can find either.
Wrong.
As long as you find
Big dummy to your face.
an angle and specify where it's from. So I can say it's 42 from the vertical, or I can say it's something from the horizontal. Doesn't matter. Doesn't matter. Okay, I. Which is I?
From which it was thrown/dropped.
Okay. So again, height. Height is that delta y thing. So look at my formulas. I say I can't use v equals u plus at because there's no delta y in there. So that's useless.
Why don't they do a question like G when you have to find its final velocity? But for H, it's just like, how long did it fall for?
Because but I wanted to cover every angle in the book without using lots of space. Okay, then I look down my formulas, I say, gee, there's a formula with delta y in front of it. Maybe I could use that one. Let's see. Do I know uy? That's 0. Yes, I know that. Do I know time? That's 9. Yes, I know that. Do I know a? Yeah, that's 9.8. Hey, I've got everything I need. I can use that formula. So let's do it. Because I'm trying to find the height, the first thing I do is I look at the formula with delta y as a subject, and I think about that.
How come the initial velocity of y is in these questions is usually 0?
Because to make it easy on you, that's how they set it up.
So I was doing the other ones before.
The other ones don't. No. So delta y is going to be uy, which is 0 times time, which is 9. That's 0, of course. Plus, and guys, you singing in the background doesn't help me very much. 9.8 times 9 squared.
Is that 0.9 of seconds?
No, that's 0 times 9 seconds. Because it's ut, initial speed is 0 in the vertical. Time is 9, so that bit just is 0. And that's a half 9.8 times 9 squared. So it's 81 something big.
400.
That's a pretty good estimate there, Riley. I'm impressed by your ability to do that.
That's what I got.
Oh,
Oh, damn it, Marty.
sorry, I'm not mathematical. Wait, I like triple.
Recorded for posterity. Okay.
It's a 0 times 9, which I don't check is 99.
So what I'll do now, guys, I'll very quickly do one more of these ones, and I'll do one of the more complex ones, and then I'll be available to help you as you work through them.
It's velocity 3 seconds after drop.
Uh,
Oh, so that's pretty easy. Just put
you just, what you do here, you do that by making that V equals U plus AT. That becomes V equals 0 plus 9.8.
Questions left. It's that one and the one that you did in your head, which is 5 seconds after drop.
Yep, times, that becomes 3. You'll get a new,
28.
you'll get a new vertical velocity then,
29.4.
29.4. And then you used Pythagoras this time, so now you got your new answer, which was 28.
Repeat question 2 and
29.4. There it is.
So that becomes 28.4, was it? 29.4. And this time, I'm an idiot. That's the vertical. That's the 80 at the top. And then you just find the resultant.
236.
Yep.
85.
There's now a recording of you saying I'm an idiot.
Yes, I know, I realise that.
85.
But no one ever downloads them, so it's okay. Except I know, yes, someone in my utilal class is now going to use that again.
I'm gonna get that. We have to buy FL Studio.
Okay. Here we go again.
Well, what are we gonna do now?
I was asked to do, well, let's do the next question, guys.
Yeah, we're listening.
Question,
Can we do one more, please?
I'll do that next. I want to just find a hard one of these. Question 4 I was being asked about. So let's do question 4. Marnie should actually be able to lead you through this one.
Not the one.
So, what you have is you have a cliff. Oh,
We did the top.
I think you did the cliff one too. Yes, you did. And I hope that doesn't get recorded.
I've said it like 3 times already.
Yep. So you have a rock.
No.
The rock is thrown out horizontally and some distance away. Now we're told it lands 80 metres from the cliff I hope that's what it says. The rock is thrown horizontally out.
Wait, which one? 4. Let's go with the
So how long are we doing this topic for? A few weeks?
Yes.
A question.
No. We can only afford a few more lessons on it. So, data. AY. We know that, don't we, all the time? So, Cody, what's your vertical acceleration? Always. So we can always write that in automatically. The only thing we have to be careful of is the direction of it. We know AX, it's always 0, so I'll put that into reminder cells. We know delta Y, which equals 147, good. And we know delta X, which equals 80. Now we've got some problems.
Let's solve for that. Let's go.
Okay. A. Can I find out my V? Whoops, no I can't, because that's not what I've asked. Can I find out my initial speed? U.
Could you use delta Y?
Okay, let's have a look at the delta Y. Do I know my initial Y?
You do the
I don't have time, I don't have UY, can't do that. D equals VT. There's an,
You can rearrange.
you can't do what's missing in the, what do you have in the downwards direction? Have an acceleration? You need to include the acceleration in your calculations.
Well, can we work out the final velocity in order to get at least another...
You don't have the initial velocity, you don't have.
Okay, so guys, this is one of these cases where you're stretching around saying, I'm lost, what can I do? So what you need to do, no, don't necessarily, hang on, let's listen in and I'll show you what you can do. You've got to find out anything you can to try and give you a way of cracking the question open. Now, what I do know, all right, if I look at the equation, delta y, do I know delta y?
Yes.
Okay.
Wouldn't U just be 0?
Do I know uy is 0? So I actually can put that in there. And that means uy no. Do I know time?
No.
No. So there's one variable I don't know. Do I know acceleration? Yes. Do I know time? That's that same variable. So there I've got an equation where I know everything except for one variable. Can I use that equation to find something out? Yeah, so let's do that because I've run out of options. So I might as well find out how long it took to fall.
So we're only just working out the initial velocity, which is just 0.
Yes. But no, the initial velocity has got sideways and downwards. So my initial velocity has the combination of the...
Still wouldn't have thrown it, so its initial velocity would be 0.
No, otherwise it wouldn't go anywhere. It's initial when we measure initial velocity, it's when it leaves the hand.
So it would have an acceleration.
Remember, it's accelerated to get it to its initial velocity.
Yeah.
But we count, when we look at projectiles, we count it from the moment it gets it.
When it leaves my hand.
Yes, when it leaves your hand. So, yes.
That V equals UAT, that can be used for the horizontal vector.
Yes.
Whereas that V squared Y, U plus 2A delta Y, is that only for the...
Where it says delta y, you just make it delta x instead of delta y, and you can use it. So I can find the time. Let's find the time out here. I can't use v equals u plus at because I don't know time and I don't know v, so that won't help me. But I can use the delta y one, so I'm going to do that. I'll just do it over here. Delta y equals uyt plus a half ayt squared. So I can substitute in. I get 147 equals, that bit's 0 because uy is 0, plus 1/2 times 9.8 times t squared, which means I'm going to end up with t equals the square root of 2 times 147 all over 9.8, which equals that's the way you rearrange it. Someone said what? I don't know why.
5.6.
5.47 seconds. Okay, now you are asked in one of the questions what the time for falling is, so at least you got that now. That's a good help. So now look at what I can do with that. I've got time. So I start looking through my formulas again. Let's look at the top one. Vy equals uy. Do I know uy? Yep. Plus ay, I know that. And t, I know t, so I can find out vy now. Excellent. That's part C. So vy equals uy plus ayt, which is going to be 9.8 times 5.47.
This is all part of that one big question.
I'm just working my way through, yeah.
Like, no. Like,
53 point something.
this question is the initial.
Yeah, I'm working my way to get that one done.
Oh, yeah.
But because what I've actually worked out in trying to find out the answer to A, I've worked out the answer to E and the answer to J and the answer to, so I'm just doing what I can do. And often in exams, what you've got to do is do what you can do. So I've just looked through the formulas and said, oh, what can I do? Well, I can find out time. Okay, I might as well do that. Found the time.
These formulas on the data sheet again.
Yes. Yep, Brad.
Oh, hang on, wait. No, I just figured out where I went wrong.
Okay, so strategy, guys. And this is what I'm actually working on with you to show you how to attack these problems, because students get, look at them and go, I can't do it. I have to find that, and there's no way of doing it. What am I going to do? Screen. No, you don't screen. What you do is you say, what can I do? Let's work my way through the formulas. I can find the time. Good. Well, the time tells me a bit extra information. What else could I plug the time into? I can do it up there. Good. That gives me a bit more information.
We don't get these formulas, do we? I know we
Yeah,
do.
they're on your formula sheet. So you can just keep plugging your numbers into your formulas, doing what you can do, and eventually you will actually get out the answer that you need. Okay, so now, having done that, what is the answer to that one, by the way? Sorry, I didn't pick it up.
24 something. 23, 23, 26. I said 3 and 6.
Now, the other thing you can do, which is really neat, is can I find out my horizontal initial? Let's look at it. I know delta x, don't I?
Yeah.
Okay, so let's look at my formulas. There's a formula there with delta x in it. Let's see if I know enough to use that. Delta x, I know that, equals ux, trying to find that, times the time, I know that, so I can use that still, plus a half ax, yeah, I know what that is, times the time. Yeah, I can use that formula to find ux. So, ux is,
So how come the initial formula's got squares in it and no time symbol? But Vy equals Uy squared plus 2a.
which one?
Vy squared equals U squared y plus 2a delta y.
What's wrong with that one? Sorry.
It's different from your given time symbol.
That one there is that formula there.
Yeah, no, the other one, number C.
Oh, that's the top one. Yeah, V equals U plus AT.
Oh, okay.
That's why. So, UX. So what I'm working on now is I'm working on this one to find UX. Okay? So UX is going to be delta Y divided by time. Now, if you don't know where I got that from, I'll show you. Oops, what am I doing? Just forgive me because I've just put the wrong symbol in that. It should be delta x on t. The way I got that was delta x equals uxt plus a half axt squared. But of course, that bit there, because ax is 0, comes out, and then I've just rearranged that to get that. Now, you could, the equation, this equation d equals vt is just a special case of that one where a equals 0, isn't it? Yep. And you could remember that extra formula, remember when you can use it, when you can't, or you can just use that general formula and sub in a equals 0 when a equals 0. It just means you don't have to remember as many formulas. Now, that means that delta x being 80, and our time was, as we've said, 5.47.
Is that a UX or a BX?
That's a U, that one. Because the formula gives you UX. So that gives you the initial speed. Now, I'm not going to work out whether that's A, B, C, D, E, which answer is, because one of the answers you're after, you can work out which one it belongs to. So again, I'll say it, I can't answer this in the order they ask you to get the answers. And in exams, sometimes they'll put the questions in an order you can't really answer them very well. So my strategy is very simple. Look at the formulas, find one that works, that gives me a bit of extra information, take that extra information, plug that into a formula, get more information, and just keep working my way methodically through until I get an answer that I want. Okay, and that's a strategy that has been used for centuries, and it's a good strategy. So having got that, can I now work out, yes?
But you have to remember what all the data, because if you don't know what A is, then you sort of stick it, aren't you?
That's right, but you always know what A is in these questions. And then they'll give you what A is, and you have to substitute. In fact, one year they did that sneakily. They gave you a projectile question on the moon, and instead of 9.8, you had to put in 1.6. Because they actually told you that. But some students in this sort of blind panic beam exam read the question. Acceleration of the moon is due to gravity is 1.6 meters per second squared. Blah blah blah. Calculate, and so then they put AY equals 9.8, and the examiner said out of habit. So you just have to watch for that. I found in a messy way. I found UX. I'll call that D because I can. Yeah. Yeah, I will. And then from UX, well, anyway, you get the version of what I'm talking about. I probably don't have to work through every other little step of the way. You guys can work it out from that point. All right, let's do what Tom wants. Get rid of that circle.
So can you do question 20?
Yeah.
Sorry, it's so horrible at reading faces. I read out one today.
Imagine Mr. Green.
No, but we did hear
How
about.
are you?
We heard about the first year 12 meetings, but not year 12 meetings.
Well, Mr. Johnson came in and told me.
Yeah, because we didn't hear it.
Okay, people, this is the next level.
Question 2, sir.
I can do. Question 2.
Actually, can we do question 1? I reckon it would just be easier.
Yeah, it's very complex question 2.
I don't mind which one we do.
Question 1, question 1.
All right.
I reckon.
No, sir, don't just sound.
How about I do question 1 now, and then I can do question 2 next lesson, and then I can leave you to it.
Question 1 all right.
You need it. I'll do it the other way round.
Question 1 all right. Yeah, question 2.
Do question 2, son.
There's the ground. It's bumpy ground. I don't know why they did that. I'm doing this one. We get a projectile that's initially fired, so it's going to do something like that.
Which one are you doing?
Question 1.
I'm doing question 2. It's fired at 30 meters a second.
Yeah, no.
And it has a range of 79.5 meters. And the time to do that equals 5.3 seconds. Now, ladies and gentlemen, there's some tricks to this that you need to know. I haven't introduced them to you yet. That's why you're going to have trouble with it. The first thing to realise is that what a projectile does is it starts with a certain velocity and it goes up to the top of the flight there, which is halfway in its journey. It'll take, because it's being accelerated at an even rate, the time it takes to get up to the top is the same time it takes to get back down again. When it reaches that point, we know something. We know its vertical velocity. Because it's got to the top of the flight, the vertical velocity must be 0. Now, that's an important trick to realise. Yeah.
That's a cue.
It's not now. There's my 0 in position. Oh, I'm very excited by that. Oh, I think technology is amazing. I couldn't do that in blackboards before. Okay. So now I need to put in some data. Let's see what we do know. First thing is I know U. Second thing I do happen to know is I know AY. Now there's a trick to this as well that you must remember. If my velocity is up and is positive, my gravity is in the opposite direction. So what do I have to do with it? Give it a minus sign, because it's in the opposite direction. The other thing I know, of course, is my horizontal acceleration is always 0. That's not a problem. Do I know the angle there? Theta, I don't know.
Has it ever been not 0?
You've got a rocket on the back or someone's pushing it with their foot or something.
So that's in the early time it's not.
You'll never get a question with acceleration sideways in it, unless they're being really nasty to you. Okay. So the first question I ask you, guys, even if you're not interested in your HSC mark, that's fine, but don't disrupt the rest of the people. Okay. The first question I ask you is the initial velocity, and that's pretty easy. I told you.
Well, we did a question.
The next question I ask you, I think, is the initial horizontal. Okay, now the thing about that is that's actually pretty easy. I've got some information that helps me do that, because I know that Vx equals Ux, and Riley's just given the hint. Ux is going to be the distance travelled over the time, 5.3 seconds. Well, don't forget.
What's the number of 79.5?
Yep, don't forget.
Equals 15.
It's 15, is it?
When you let it work it.
Don't forget that its rate of travel is uniform across that time. So the travel to 79.5 and 5.3, that's the speed it has to be doing sideways. Okay, so that's easy. C is going to be UY. That's a little bit harder because the angle is important in this one. Okay, so I've got to work out some stuff that I might know. Now, what's delta Y in this problem? The height. So delta Y is going to be that distance there.
Shouldn't it be 2 of that because it has to get up and down?
No, delta. If I say my time is half of that, can't do that. But it takes 5.3 seconds to get from there to there.
Yeah.
If I halve that, where is the? It's up to there, isn't it? So that means delta Y at that time is that height, which is when Vy equals 0. Okay. So what I can do now is I can look at this and I say, which formula have I got that's going to tell me something? Let's look at that delta Y formula. Delta Y equals UYT plus a half AYT squared. Now I know delta Y. I want to find uy, so I don't need to. I know the time, I know the acceleration. So that formula is one I can use. And the only thing I don't know in it is uy, isn't it? So I can use that formula to work it out. So delta y is the height. Now I'll show you. Have we been given that? Oh, I made a mistake. Okay, we'll have to work out what delta y is. Can I do that?
Yeah, because you have the time.
So I tried to use my paper.
Sorry. No, you can't use Pythagoras. The reason, okay, you can't use Pythagoras because it's accelerated.
Yeah.
It's being accelerated. It changes, it goes through. Let's try this formula. Let's be sensible about this. Vy equals uy plus ayt. Now, the reason I can use that one, I'll re-explain. Halfway through its journey, Vy is 0. So I know that, not a problem. I want to find that one. I know Ay, and I know the time when Vy is 0. So what I can do now is I can substitute in, and I say Vy is 0 equals Uy plus Ay, sorry, Uy plus minus 9.8, because I have to remember the direction is important, times the time, and the time is 5.3 on 2, because it's halfway through its journey when Vy is 0. Yep.
Why do you set V1 0?
Because when it gets to its highest height,
They go up and down.
It's like 24.8.
yes,
I thought you just use calculus.
there's no reason you can't, but we don't do calculus in this course because they think it's too hard for you.
But then they, oh no, you can do it in normal maths, you'll be fine.
But in this case, I know that halfway through its journey, Vy is 0, and it has that height. So what does it turn out to be?
Minus 25.7.
No, it's 25.97. The reason is when you rearrange it, right, that becomes a plus when it goes over the other side of the equation. Okay, so now I can find theta if I want to. I don't know if I particularly want to or need to. So what's D? What's D? It's range, isn't it?
Yep.
We know the range.
And then for delta y, you use the half
Delta y, which as you say is uyt plus a half ayt squared. Now, the trick with this one, guys, delta y is being measured halfway through the journey again. And the other thing to remember is that ay is negative. So delta y is going to be uy, which we worked out before was 25.97 times the time, which is the 5.3 on 2, plus, hang on, 1/2 times minus 9.8 times 5.3 on 2 all squared.
So, why does, if you put the just normal times, what the range would
The height you'd be finding is there, which is 0.
So for the library.
The maximum height occurs halfway through the flight.
I was typing when I said like a splash thing.
Right. Just calculating it out.
So when I did that, when you give me 0, it gave me
Minus 300 and...
Yeah, well then you've done it. You've missed something. Like I don't know if you haven't used minus 9.8 in it.
Yeah, so minus 9.8 times 5.3. 5.95 times 5.3 times by...
I'll have to have a look. It should be.
0.5 for that just now.
No, something's wrong in there.
Wait. 25.97 times by 5.3 on 2 plus. Is that a plus?
Yep.
Alright, I'll put that in brackets now.
I got 111.671, but that can't be right either.
Why?
Because on 10 the ground, it can't be 111 meters on the ground.
No.
I'm still getting 0.5. So, yeah.
Okay, it might only be a very small. I don't think that's the answer I got when I did the other day. I'll check it out anyway.
Still tapping my
Go
calculator.
the answer, sir.
Is it negative 9.8? It's
Yes.
times negative 9.8.
Yes. So what do you get?
34.41025.
4-1.
Yeah.
Whoa. Hang on, I also missed something else then. 9.8. Maybe I did times 9.8 by the brackets, but that would make a difference.
Anyway, it's
I need square it. 4.41.
so that's correct.
Calculators agree now.
But then, so can you tell me what? I don't understand